Hi, my name is David Clare, and this is Group 3's presentation on the HEC-HMS final report. HEC-HMS is a hydrological modeling system. It was created in 1992. This modeling system can simulate precipitation and runoff processes for watersheds with multiple streams. It can model large river basins and watersheds of all sizes. This wide variety is one of the reasons people use HEC-HMS. It can also create lumped or distributed models as well.
Hi, my name is Chris Carcito. The site in question is located at San Gabriel Mountains in Pasadena, California. 4 major subbasins are included in our analysis: Arroyo Seco, Colby, Little Bear, and Lower Arroyo Seco. Critical data such as area, percent impervious, length of flow path, and average slope are all taken into consideration within this report.
Hello, my name is Julio Lopez, and I will be talking about the reduction in curve number. The curve number 72 was selected for both the lumped and distributed models. However, after establishing baseline models, feedback suggested that the selected curve number was too high. This conclusion was based on 2 observations. The first was based on sensitivity analysis done that resulted in significant peak flow difference, and the second was based on personal observation while hiking in Southern California's forestry and terrain, which provides a clear indication that the quality of cover ranges from fair to good during normal and wet year conditions. The feedback provided in the sensitivity analysis shows that the curve number was the most influential parameter, a curve number ranging between 36 and 54 for the lump models and 25-48 for the distributed models. The difference in the curve number ranges allows for parameters to be adjusted more specifically to each sub-basin characteristic.
Hello, my name is Dakota Newsom, and I will be discussing how we finalized our optimal parameters sets for both the lumped and distributed models after calibrations, using an observation matrix as well as a base flow analysis to determine the difference between wet and dry years. The observation matrix, which is shown in the slide, allowed us to compare global maximums and minimums for each storm and select parameters that best fit the entire model, vice each storm. The base flow analysis was completed using a matrix and a standard deviation from the monthly averages that provided a true result for months experiencing more rainfall than normal and a false result for months that performed below the monthly averages. These were then summed and concluded which years were in fact wet and dry. This allowed us to better tailor our models to wet and dry years. Thank you.
Hi, I'm Wayne Thorne. I will discuss lumped versus distributed results. Which model do you think performed better? Well, let's see. In a world where data is currency, where even boring old baseball has sabermetrics, the distributed model is preferred. It's more accurate and more detailed. Each sub-basin has the influential curve number and lag time, instead of lumped with one curve number and one lag time. Using free HEC-HMS software and Excel, the distributed model stats showed lower root mean square error, or RMSE, and lower percent bias for the gargantuan Storm 5 flow. The top figure confirms that the orange peak distributed flow came closer to the blue peak observed flow. Looking at the bottom figure, Storm 6's orange distributed model hydrograph, with higher RMSE and percent bias, still more closely matched the blue observed flow hydrograph. And yes, there was some overestimation of distributed flow. Hopefully, with more experience, these results and models, especially the preferred distributed model, will increase accuracy and trust, so water resources designs will have a higher factor of safety at the lowest possible cost.
Hi, my name is Dakota Adelphia, and I'm going to talk to you about some recommendations that our team came up with for better results in future labs. It is difficult to model storms in California due to many factors that create large changes in storm events. There is a vast difference between storms that occur in wet years and in dry years. The percentage of vegetation varies each year, creating changes in the ground cover. Fires in California can also affect the ground cover drastically. It would have been more accurate if we had used different parameter sets for wet years and dry years, rather than how we did, which was only adjusting the base flow. We believe our final results would have been better if we had looked only at storms in wet years or storms in dry years, rather than a mix of both. We also believe our results could have been better if we had a larger sample size. Only having a few storms made it difficult to get reliable storm data. Additionally, if we were familiar with HEC-HMS prior to these labs, our results likely would have been better. There was a significant learning curve and many user errors occurred. Even proficient modelers like Ryan Edgley still have to patiently build and debug models, which is a time-consuming process.